Good morning, good afternoon, and good evening. Hope that you are all doing well and staying safe. Here is Mirna Ahmed, Senior Petroleum Geologist student at Matruh University. Welcome to the third lecture of our online course, Shale Evaluation, presented by special guest speaker Dr. Ahmed Algarhy. Dr. Algarhy is the director of the BioPetro non-profit educational project, and also he is an assistant professor at Marietta College in Ohio, USA, where he teaches production and completion geomechanics and unconventional reservoirs evaluation and development. Finally, Dr. Ahmed holds a PhD and MSc in petroleum engineering from Texas University. In addition, he holds MSc in petroleum engineering, natural gas engineering, postgraduate diploma, and BSc in mining engineering from Cairo University in Egypt. So please join me in welcoming Dr. Good. So welcome Dr. Ahmed Algarhy. Now,
Welcome, Mary.
as a reminder, if you have any questions related to the technical session, please feel free to drop it down in Q&A section. Now, without any further ado, Doctor, the mic is yours.
Hello, everybody. Thank you, Myrna, for the nice introduction. Today, as you know, this is the third lecture. We have four lectures, and this is, the third, and tomorrow we'll have the last one. Then you will start getting two lectures with Engineer Pietro Galli. Okay, so in this class or in this lectures, we are discussing how to evaluate shale and how to develop shale. I'm trying to give you like a short introduction about that. Okay, so 5 years ago, maybe 6 years ago, I wrote a paper with colleagues about new technique to evaluate shale. And I found maybe it would be valuable to share this information with you. Okay, so this paper presented in SPE conference. It was in Egypt, and at that time I was in the United States. So my friend Dr. Walid Afifi presented the lecture, and we had also, beside myself and Dr. Walid, we had Mr. Richard Bateman. We had Dr. Mohammed Solomon, and all we were working, me, Richard Bateman, and Dr. Solomon, we were working for Texas Tech University. And Dr. Walid Afifi at the time was working for Khalda. Now he's working for Oasis Petroleum Company. Okay, so let's get started. Okay, so today I want to show you an innovative technique to grade and scale shale sweet spot. Guys, most of you are from, let's say you know how big is Cairo or how big is Alexandria, for example. Assume that all Alexandria, all Cairo has a layer of organic shale below it. Okay, I cannot develop all that area. This is huge area, correct? So I need to find the best places. Then I will get my drilling rigs. I will get my pumping team, and I will drill and frack and produce. Okay, so our job now is to find a good shale play or a good shale formation. Then we will decide where is the best spots in this shale formation. This best spots is the top spots. We call it sweet spots. So when I tell you I want to grade or I want to find shale sweet spot, it means I want to find the best place in that shale, the highest quality in that shale. Okay, we call it a sweet spot, shale sweet spot. Okay, so I will try to show you a technique to evaluate this sweet spot. Okay, so to evaluate a sweet spot, there is a combination between different factors. There is some geological factors, there's some engineering factors, there's some economic factors. And all of them are very important during evaluation. Okay, so let's get them one by one. Guys, I need to check how much is the TOC. TOC is the total organic carbon, total organic content I'm having. And it will be great if I have more than 1 or 2%. This is the organic content, the percentage of the organic content over the, from the whole volume. Okay, let's say I have this cell phone, for example. Assume this is a volume, and I will ask myself what is the percentage in this cell phone is TOC, is organic content. Okay, so if it is 1% organic content or 2% organic content, I will say the TOC is 1 or 2%. Okay, for sure, whenever I get higher percentage of organic content, it will be great. I'm expecting to see something maybe anything more than 1% or 2% will be great. Okay, but it will not be, if you get very high number of TOC, most likely there is a mistake, or you are evaluating a piece of coal in a mistake. You expected a shale, but it is not a shale. Okay. Thermal maturity. Thermal maturity, it means you need to know what is the S1 and S2 and S3. This is, you do the pyrolysis testing, for example, and you decide which type of hydrocarbon you will be producing. This reservoir of this shale will produce oil or condensate or gas, for example. Why is this important? Because the price of these things are different, and I need to know exactly how much money I will be making. Okay, thickness of the formation. Maybe this shale, this organic shale formation is 100 feet thickness. Maybe it is 50 feet. Maybe it is 500 feet. Whenever it is thicker, okay, this would be better. So anything greater than 100 feet thickness, I will. This would be great. Okay. Also, I need to check the heterogeneity. Shale, any shale by definition it is heterogeneous. So I'm expecting any shale to be heterogeneous. Okay. Type of structure, the gas content, the areal extension of the areas at this, a sweet spot. This, let's say, what is total area of that sweet spot? I know the thickness, and now I need to know the area. Also, the rheology. Let's say what is the content of it, how much is, what is the percentage of the shale, and what is exactly the clays in the shale, for example, how much is the organic content, how much is quartz or limestone or dolomite or anything else. So I need to understand exactly the chemical composition of the formation. Okay. Also, I need to understand the porosity. Guys, if the porosity is too low, this is not nice. If I have a porosity of 5% or 7%, this would be awesome. Okay, so I like to have big or large porosity, because porosity, this is the storageability of the formation. If I have big pores, it means there is a high chance to have a big amount of hydrocarbon. Okay. Also, I need to check the reservoir pressure. If I have a reservoir pressure, high reservoir pressure, for example, this will be favorable. This is something good. And I mentioned to you the Amoon project, and the project done by Khalda 10 years ago. And one of the bad things, we noticed that the reservoir was, its pressure was too low. So if you have low pressure reservoir, low pressure shale, organic shale, this will not be something good. Okay, the gas composition I'm producing, the geomechanical parameters like the Young's modulus and Poisson's ratio and UCS, these things will be important whenever I will think about fracking. Whenever I'm planning to hydraulic fracturing, I will like to have all the mechanical properties, such as Young's modulus, Poisson's ratio, and the UCS. Okay. Also, there is some economic factors like the price. If I'm talking about gas, so this I need to know what is the gas price these days. If I'm talking about oil, I need to know what is the average oil price. Not only these days, it is better to have a good prediction for the next 5 years, because shale projects is like big projects with big investment. We invest a lot of money, so I need to have um, a good average or a good prediction for the oil and gas prices for the next 5 years. Okay. Also, I need to know something about the taxes and paying, the environmental factors, and the ultimate recovery, the estimated ultimate recovery of that gas. Okay. Okay. So before we move on, I want to remind you again that a sweet spot or core, this is represent the concurrent of several favorable factors. And again, this is the best location inside a shell. Okay. And I'm trying to find this place to start my drilling and fracking activity. Okay, so let's show you a good summary for what we can consider a good sweet spot. A good sweet spot, I may have TOC, or total organic carbon, and this is a percentage of weight, something more than 2%. And some other experts will say, hey, more than 1% is enough. But let's say starting from 1 or 2% and higher, this would be great. Okay. Also, for sure, I need to know some good information about the geology, the deposition, the geologic ages of this source rock. So this would be important to know. Also, for S1, S2, S3, and Tmax, the maximum temperature and hydrogen index and production index, all these things are important because I want to know exactly the type of hydrocarbon I will be producing. Guys, we have a famous shale play in the United States in south of Texas. Its name is Eagle Ford. And Eagle Ford in some places produce gas, in other places produce condensate, and other places produce oil. So these different locations in the same shale play, they have different depths. The formation is slanted. So in the deeper part, it produces gas because the temperature and pressure will be higher, and in the middle will be condensate, and the shallower part will produce oil. Okay. And again, the thermal maturity and S1, S2, and S3, and Tmax, and these things are related together. Okay, porosity and permeability. I need to have good porosity, and I need to have permeability more than 100 nanodarcy. Guys, nanodarcies is something very, very low. This is 10 to the power of -9. So something very, very low permeability. When you have 100 nano, 500 nano, this is extremely low permeability. Okay. Also for the porosity, it would be great if I have something more than 2% porosity. Okay, 5% would be great, 7% would be great. For the thickness, I like to have a thick organic shale formation more than 100 feet. It means you will have enough amount of hydrocarbon. So whenever you invest your money, you know that you will get more money. You will make money out of it. Okay. Regarding the depths, we have here in the United States many different shale plays, and the depths are different. So in some shale plays, you have it is a shallow depths. Others it would be deep ones. For sure, if it is less than 15,000 feet depths, this would be better. So shallower depths will be better. Why? Because the drilling operations would be cheaper, for example. If it is very deep, it would be more challenging. Okay, so if I have something like 10,000 feet or 8,000 feet, this will be great. Okay, there is something we call brittleness index. the brittleness index or frackability index. Whenever we have this number high, like 50% or 60% or 70%, like high brittleness index, it means this formation is brittle. It means whenever you frack it and you break the formation, you will create a lot of complex fracture network and you will produce a lot of oil. So we prefer to have a brittle formation, and we prefer to have brittleness index 50% or higher. Okay, so remember this: the brittleness index or brittle formation, when you frack it, you will produce more oil or gas or water, because if you frack in a water zone, you will produce water for sure. But this is not what we want. If you in the formation you are fracking on the shale formation, whenever you have more quartz, this will increase the Young's modulus and will increase the brittleness. So whenever I have a shale formation and I know that I have, let's say, 30% quartz or sandstone, I know this formation most likely would be a brittle formation. Guys, whenever we say a shale formation, it is a common mistake when you expect it is 100% shale. Whenever we say shale formation, I mean, let's say more than 50% shale. But the remaining, maybe some quartz, maybe some sandstone, maybe some limestone, maybe some dolomite, or maybe a mixture of all of them together. Okay. Here is a new stuff we presented in 2015. It was, its name is Sweetspot Quality Index. I told you Sweetspot, shale sweet spot means the best place inside a shale play. And Sweetspot Quality Index is a technique to evaluate that sweet spot. Why? Because maybe I want to compare the sweet spot I'm having here at Marietta, for example, with a sweet spot you have it in Alexandria. Also with a sweet spot you may have it in Cairo. Okay, so it is a visual way to compare the quality of shale sweet spot with other shale sweet spots that we already know it was successful, for example. Okay, so let me show you how it works. So the sweet spot quality index, or SSQI, is a technique to grade and scale shale sweet spot to facilitate financial and development decisions. Guys, there is a lot of information here in this shape. Okay, so whenever I look to this, I can get an idea about reservoir quality. Whenever I look to this shape, I can get an idea about the completion quality. Whenever I look here, I can get an idea about the conventional behavior. When I look here, I can get an idea about the operation index. And I will explain each index of these four indices. So the sweet spot quality index, it is a one index, but to calculate it, I need to calculate it using four indices: reservoir quality index, completion quality index, conventional behavior index, and operation index. And simply, I will calculate the area inside this polygon, let's say this red one here, the polygon in the middle, divided by the total area of that orange polygon. Okay, so it may be 20, here it was 0.24, means this red part, when we divide it over that orange part with a big one, the big polygon, you will get 0.24. Okay, so let's explain what is the reservoir quality index and what is completion quality index and what is conventional behavior and what is operation index. Okay, reservoir quality index is defined by the combination of properties leading to storage capacity. So any parameter will add to the storage capacity. I will consider it part of the reservoir quality index. Okay, and also if it adds to the producibility of that formation, I would consider it part of the reservoir quality index. Okay, so these properties may be organic richness, TOC, maybe the effective porosity, maybe the matrix permeability, maybe the saturation, okay, maybe the mineralogy. So all these things, I may use it to calculate the reservoir quality. Okay, and mainly this is storageability and producibility. Okay, the second index, what we call it, completion quality index. Completion quality, whenever in shale, whenever we say completion, means I'm talking about hydraulic fraction. Whenever we say completion, it is something related to hydraulic fraction. Don't forget that. So completion quality is defined by the combination of formation properties that contribute to the creation of surface area contacting the wellbore with the reservoir. Actually, this is exactly the definition of a hydraulic fracture. The hydraulic fracture will increase the contact area between the reservoir and the wellbore, for example. So this is exactly the same definition. So any parameter will add to completion quality or add to the quality of hydraulic fracturing. I would consider it in my calculation of completion quality index. Things like what? Think about the brittleness, the Young's modulus, Poisson's ratio. These things will add a lot to the completion quality. Okay, think about existence of richness of quartz. Whenever I have more quartz, I know that the Young's modulus will be higher, most likely. Okay. Okay, now let's discuss what is conventional behavior. Guys, we noticed sometimes inside a shale, organic shale formation, in the middle, we find a thin conventional reservoir. Let's say a few feet of a conventional reservoir. Maybe it was sandstone, maybe it was from limestone or dolomite. Okay, and this conventional reservoir, which is very tiny in the middle, will be charged with hydrocarbon, maybe gas, maybe condensate, or maybe oil. Okay, so if I have that tiny conventional reservoir in the middle, I will consider that in my conventional behavior index, because whenever I will produce, I will notice my production as some kind of conventional behavior production, similar to a sandstone reservoir producing, for example. Okay. Okay, and the last one is the operation index. And operation index, anything related to money, cost, environmental issue, safety. These things are changing. Okay, for example, if I wanna produce shale from Libya, for example, and Libya was not in the best security situation. Let's say there is some unrest, and I will ask you or ask your company to go and do some business in Libya. You may tell me, hey, this is not safe. I will not go. Why? Because there is some security issues. Okay, maybe I will ask you and say, go and do some work in shale in Algeria. And Algeria and Libya, both of them, they have huge amount of shale oil and shale gas. Okay, so you may tell me, hey, we don't have enough horsepower there. We don't have enough pumps. We don't have enough fresh water. So these things, I can consider it in my operation. Okay, I will give you more examples very soon. Okay, so the reservoir quality index can be represented by gas in place, calculating gas in place or oil in place per section. This is as simplification. If you want to simplify things, okay, you can ignore the other parameters and you can consider, other parameters related to reservoir, and you can calculate the gas in place or oil in place per section, and you can consider it, this is my reservoir quality index, and I will show you how we do this. Okay, so Section here means 640 acres. 640 فدان. 640 acre. This is what we call it section. Okay. So I will calculate the gas in place per section, or the oil in place per section, and to know that I need to know the porosity, the saturation, and a lot of other parameters. These parameters I can get it using a triple combo logs. Also, I can get it using a triple combo plus ACS gem and flex tool. These tools we use it to geochem log the formation. Okay. Also, I need to know the rock evaluation pyrolysis, S1, S2, and S3, because I need to know exactly what type of hydrocarbon I'm producing. Okay. Remember, whenever you are talking about gas, there is two types of gas. There is a free gas, that gas inside the pores, and there is actually there are three types of gas. Free gas inside the pores, and adsorbed gas absorbed in the surface inside that layer, okay, and adsorbed gas inside the kerogen itself. And the kerogen, this is a container that includes a hydrocarbon, okay. So I need to consider all of these things. Okay, now let's talk a little bit about the completion quality index. And as a summary, I told you completion quality index is anything related to hydraulic fracturing. Any parameter will impact the hydraulic fracturing. So the completion quality index represents the quality of the completion of the quality of the hydraulic fracturing job I will be doing later. Look, this is a horizontal well. I told you, look to the mouse. This part, I call it the toe. And this part, I call it the heel. Okay. So this is a toe. This is the heel. If you look to your shoes, you have, here is your toe, and here is your heel. And I will frac this part first, then this part, then this part, then this part, and so on until I reach the heel. So I start from the toe, going backward to the heel. Okay. Also, I will consider the natural microfractures and sand lamination. I will consider the brittleness, all these things. I will consider the chemical composition of the formation. All these things will impact the hydraulic fracturing. But to simplify it for you, I can consider only the brittleness index. So whenever we talked about reservoir quality, I told you can consider the gas in place or oil in place per section. Whenever we talked about completion quality, I told you to simplify this situation, you can consider only the brittleness index. Okay. Example for conventional behavior, guys. I believe this lecture today will be a little bit short. So if you have any question, try to write it down in the Q&A section. And for sure, Myrna will ask these questions. We'll ask me this question at the end. So let's continue. So conventional behavior index, I told you this is a special case. Whenever you have your shale formation, you have a tiny, smaller conventional reservoir in the middle. Okay, this formation, this log from the Western Desert in Egypt, and look here. Look to these two places, this part and this part. Look to the mouse. Here and here, all that red section, this is shale, this organic shale. But here in the middle, this very tiny place, it is sandstone formation, highly saturated with condensate. Is it something good or bad? Myrna, what do you think? Myrna, do you hear me?
Yes.
So if you have this little reservoir in the middle and it is saturated with condensate, this sandstone formation with a lot of condensate in it, is it something good or bad? What do you feel?
I think it's good.
Yes. So whenever you have a shale and I'm trying to get the hydrocarbon out of the shale, if I am lucky, I will have some conventional layers in the middle has a lot of condensate or oil or gas. Okay, so conventional behavior, this index will measure how many of these tiny layers, conventional layers, including hydrocarbons. Why we invented this conventional behavior index? Because we noticed there is many shale plays worldwide, including a phenomenon like this. Okay, a shale formation, a thick shale formation, but in the middle there is a tiny layer of sandstone or limestone, and it includes a lot of hydrocarbons. Okay. Operation index. Operation index, this is a special index because it is dynamic. Its value will be changing. Maybe the operation index of a specific sweet spot today will be different from the operation index of the same sweet spot after a month or after a few days. Do you know why? Because the hydrocarbon prices keep changing. Sometimes oil price or gas price will go up, sometimes some days will go down. Okay. Also, I need to consider the shale play depths, because the shale play depths will give me a good idea about the expenses of drilling. Guys, if you have a shale formation, Merna, I will ask you a second question again. So assume I have a formation very deep at 15,000 feet. And I have a second formation at just 5,000 feet depth. Which one will be easier to drill and cheaper to drill? The one at 5,000 or the one at 15,000? What do you think?
Please question again.
Okay, I have two formations, two shale formations, one at 5,000 foot and the other one deeper at 15,000 foot. Which one will be cheaper to drill? The shallow one, which is 5,000 feet depth, or the 15,000 feet depth? Let me help you.
I think the shallow one.
Yes. So the shallow one will be easier because I will reach it sooner, and it will have less cement, less drilling operation, less casing, so it will be cheaper. Okay, so whenever I have a good sweet spot and it is, let's say, at 5,000 feet depths, I will be happy. If it is at 10,000 feet, this is okay. If it is at 15,000 feet, this is too much. It will be expensive. And whenever I have something expensive, I need to ask myself how much oil or gas I will be producing, and what is the oil and gas price at that days, and how much money I will be making. Okay, so it is economic decision. So operation index mainly related to economic things and safety things too, which is economic also. Okay, so this is a depth, and depth will give you an idea about the expenses of the drilling expenses. Also, the availability of equipment and material. Guys, believe it or not, if you want to do a big frac job in Libya or in Egypt or in Algeria, sometimes we may don't have enough equipment to frac, or we don't have enough material to frac. Assume you need to do a big job, and that big job, when we frac shale, we need 40,000 horsepower pumps. If you collect all the pumps owned by Halliburton, Schlumberger, and Baker in Egypt, it will not be 40,000. So availability of equipment and material, this is something very, very important. Also, if you will use a special proppant, let's say I need to use a special proppant, and assume this proppant is not available in your country, and you need to get it from a neighbor country. So this is also important to think about. Okay, also safety is important. Guys, there is many countries in the Middle East, it gets some safety problem. Let's say in 2003, it was a war in Iraq, for example. Okay, so assume a company want to develop some concessions in Iraq at 2005. maybe some engineers will have an issue with security. Okay, in 2011, there is a big safety problem happened in Egypt, in Libya, in Syria, for example. So assume a company want to do some job in Libya during that time, or want to do some job in Syria, for example, at that time. So safety will be a big concern, and this will add a lot to the expenses. You may ask me, if you want to send me there, you may ask me 2 or 3 times my salary, and I will still say no, I will not do it, right? Okay. So here is the Sweetspot quality index. The reservoir quality, look to the mouse, reservoir quality index. I will make a scale from 0, from here in the middle, 1, 2, 3, 4, 5. The other side, completion quality index, 0, 1, 2, 3, 4, 5. Here is the conventional behavior index, 0, 1, 2, 3, 4, 5. Operation index, 0, 1, 2, 3, 4, 5. Okay, so this is the scale I propose. If you don't like it, you can propose your own. This is not a Quran or a Bible. We can change this. So inside your company, you can change this. Okay, but all your company should agree on the scale you are using. Okay, so this scale in 2015 makes sense to me and the authors of the paper. Okay, so let me show you what I did in 2000. Regarding the reservoir quality, if anything, let's say, if any section include 250 BCF, billion cubic feet of gas per section, I will give it a value between 4 to 5 on the reservoir quality scale. So it will be here, something here. Okay. If it is something between 200 to 250 BCF per section, I told you section is 640 acres. I would give it a value between 3 and 4, and so on, from 150 to 200 BCF per section, from 100 to 150, and if it is less than 100 BCF per section, I will give it something between 0 and 1. Okay. The brittleness index will introduce the frackability quality. If the brittleness index more than 60%, I will give it a value between 4 to 5. So it will be something here, for example. If it is from 50 to 60, I will give it a value between 3 to 4. It will be here's 3, and here's 3 and 4. So it will be something here, and so on. So I propose a scale for reservoir quality index. This is the first column. Scale for reservoir for completion quality index. This is the second column. And I use the depths to tell something about the operation index. This is not very accurate. It is my assumption. Okay, but because I need to consider also the price, the oil price and gas price. I did not do that at that time. Okay, so I considered only the depths. Okay, which is important, but also I need to combine with the depths. I need to combine with it the oil or gas price at the time. Okay, and remember, this column will be dynamic and changing over time because the price, the expenses, and the price of the gas or oil will be changing over time. Okay, this information is a summary because there's a lot of people will ask, hey, you plotted a lot of things and we don't know from where you get this information. Please tell us the source of that information so we can decide if we will trust this or not. Okay, so this paper published by a famous scientist called his name is Algarhy, and this published in 2012, and it was a combination. He collected information from famous shale plays in the United States, in North America. This is the Marcellus, This is Hinesville. This is Bossier. This is Barnett. This is Fayetteville. This is Moscow. This is Watford. This is Eagleford. This is Utica. This is Mountain. They are famous shale plays in the United States and Canada. And here, he gave good information about the age, the depths, the adsorbed gas, the free gas, porosity, the permeability, the gas in place per section, and so on. So there's a lot of information in this table. So I use this table to plot these things. Here is a sweet spot quality index of Marcellus. Here is a sweet spot quality index of Hinesville. This is for Bossier. This is for Barnett. This is for Fayetteville. Okay, and so on. And part of this work is to compare these things with shale sweet spot we found in Western Desert. Maybe in 2015, we did not have the permission to publish this information and tell exactly the location and the company and these things. But actually, we were trying to answer the question, that place in Western Desert, is it good or bad? Okay? And we found, as a conclusion, we found a lot of good properties in the Western Desert at Amun shale play. But the only bad thing about it, in my opinion, was two things. So we found very good brittleness. We found very good amount of hydrocarbon. It was great, awesome. But we found two problems. Number one, it was deep, very deep. So drilling will be expensive. Drilling horizontal wells, many of horizontal wells in that place will be expensive because depth was, I believe, something more than 13,000 feet. Okay. Number two, the formation pressure was too low. So the pressure gradient was something like 0.2 something, which is very low. Okay. So these two things, besides the oil price, the oil and gas price will help you to take a decision to invest money in that place or not. Okay, but I believe in 2014, the oil price was too high. Apache was happy because of the price, but later the oil price started to go down. So I believe Khalid Aziz stopped that evaluation because the oil price went very low. Okay, so as a conclusion, guys, please write your questions. I'm almost done. Okay, the Sweet Spot Quality Index, SSQI, is a technique to grade and scale shale sweet spot to facilitate financial and development decision. Guys, if you work for a company, after a period of time, for you as an engineer or as a graduate of Faculty of Science, when you are a new hire, for let's say the first 10 years of your work, you do a lot of technical work by yourself, by your hand. Okay, but after 10 years experience, you start doing more managerial job. So if you go to talk to the CEO of Khalda today, or if you want to talk to the CEO of Betrobel today, or if you want to talk to the CEO of Agiba today, for example, you will find him more decision maker, more manager than a technical guy. Okay, so that technical guy need to have an easy, managerial guy need to have an easy way to visualize a lot of information, something to help him to take a decision, is it a good sweet spot or not. So this technique of sweet spot quality index is a good way to visualize a lot of information in an easy way, and it will help a lot the managers or decision makers to take financial decisions. Okay. Good shale play has a sweet spot quality index value between 0.1 and 0.3. This is based on our comparisons. Okay, and we again Barnett and Marcellus, and Barnett and Marcellus, they are very famous. Marcellus is very close to me. I live in Ohio, and Marcellus is like maybe like 100 miles away from my home. Okay, so it is huge, but it is close to Ohio, it is close to West Virginia, and most of it in Pennsylvania and New York. Okay, Barnett, this is at Texas, and Utica, it is not here, but Utica here in Ohio. Okay, so the sweet spot quality index value has a clear technique and economic significance. Makes sense. The sweet spot quality index should be calculated based on present day value, TOC and S1 and oil price and these things. So you need to update it every month, for example. The order of 4 indices is very important, guys. I told you before that I'm calculating the area here in the middle, and I will divide it by the total area. So if you change the order of these indices, look, here is the reservoir quality index, and here is the completion quality index. They are in one diagonal. In one diagonal, here is the reservoir quality, and the other side is the completion quality. If you change, let's say, if you put here at the top the reservoir quality, and you put in the other side the completion quality, and when you compare it, you put reservoir quality here, and you put here completion quality. If you miss this order, you will get wrong values for sure. So you need to respect the order of these parameters. So number 1, reservoir quality. Number 2, completion conventional behavior. Number 3, completion quality. Number 4, operation index. You need to follow this order. Otherwise, you will make a lot of errors in your calculations. The reservoir quality index, and completion quality index should be in the same diagonal. This is to get the right answer. In some cases, strengths in one of the 4 indices may compensate for a weakness in the other indices. It means, let's say you may have super good reservoir quality index, but the completion quality is too low. So maybe you have something good in one parameter and something bad in one parameter, but the average between them can handle the situation, and you can still go ahead and invest and produce and make money. Okay, when using the SS, the sweet spot quality index, consistently, it is important to minimize uncertainty. Yes, we already mentioned that. And to overcome the error that results from weighting the parameters used in the calculating the sweet spot quality index, I told you how I gave the scale from 0 to 1, from 1 to 2, and from 2 to 3, and from 3 to 4, and from 4 to 5. But if you don't like that, you can build your own scale, but you need to discuss it with your company, and you should get an expert. And that expert will read your scale and say, hey, this makes sense. Because in a lot of cases, we need to benchmark with best practices of experts in that industry. Okay, thank you very much. I'm done with today's lecture. Myrna, you can go ahead and ask questions.
Okay, thanks, Dr. Ahmed. We have 2 technical questions. First one, Ahmed say, when we have finished the multi-stage fracturing, we set the bridge plugs and then we decide to drill the bridge plugs like the video that you have shown in the previous lecture.
Yes.
Is the drill string size less than the tubing size to pass through it and to drill the bridge plug, or there is no tubing?
Okay, this is not related to today's lecture, but I'm happy to answer this question. There is 4 lectures if you are interested, and I see you have some kind of experience with your talking, because this is not a question of a student. So here's what we are doing. Look to my arm. Here is a toe. I will frac the first stage. Let's say I will perforate, then I will frac, then I will set a plug, then I will go and perforate again, and frac again, and so on. So we have 2 teams working, a team for just pumping, for fracking, and a second team of, we call it plug and perf, and they are using the wire line. they're using a wire line. Okay, and you set a lot of plugs, and at the end you need to drill these plugs. We can drill these plugs using many different techniques. So I will not get a drilling rig to drill this. This is like I can use something over a wire line to drill it to. Something like with a small motor, and I can go and drill these plugs. Okay. So also I'm recommending you to watch. We have 4 videos at PyroPetro done by Aaron Barton. So try to search about Aaron Barton. He made a class with PyroPetro about multi-stage fracturing. Aaron was an expert in multi-stage fracturing. He used to work for like maybe 10 or 15 years with Baker Hughes here in the United States. And you will find all the details you can imagine in these 4 videos. I wish this answers the question.
Okay, the second one, Gloria say, how we calculate the absorption gas.
Okay, so absorption gas, there is a lot of things. This is really a tough question. You know, there is 3 types of gas. Okay, we have inside the shape. Okay, because this is based on our analysis. So if I'm getting some cores from the formation, for example, I can get an estimate. I notice there is, or the scientists, you notice there is free gas, which is a gas exactly located in a free phase inside the pore itself. Okay, and also there's some gas stick with the surface. This is by absorption. This is a physical phenomenon. Okay, also there's some gas absorbed inside the corrosion itself. Okay, so I believe there is a lot of analytical techniques, but it is not accurate. I mean, any equation to get you an estimate for exactly how much adsorbed gas, or any equation will give you an estimate of how much adsorbed gas inside the corrosion. This is just an equation, but something you cannot trust. Okay, so I believe a tool like, let's say, the NMRI log can give you a good idea about it. So the MRI log, the magnetic resonance log, can tell you exactly the type of the fluid inside that formation, and can tell you exactly what is movable and what is not. But dividing the gas and measuring, for example, and classifying, this is free gas, this is adsorbed gas, this is adsorbed inside the corrosion, I believe this is too hard for the technology to do it at this stage. We can get some averaging, but I doubt if this was accurate or not. We can do it only, I believe, in a lab scale, but in a field scale, I believe this is too hard to measure it. Okay, do we have more questions?
Yes.
Sure, go ahead.
Okay, the last question is that what is the problem of formation low pressure, and it a static or dynamic factor while drilling?
Okay, whenever you have a lazy reservoir means he's sleepy, he don't want to produce, there is low energy inside it. So, and this is mainly because the pressure is too low. If the formation is highly pressurized, whenever you drill, it want to flow immediately, it want to produce. So whenever we have high pressure formation, or a pressure within the range, the formation itself will like to produce immediately. Whenever you perforate, whenever you frac, the formation has a tendency to produce. But whenever the pressure is low, it seems like it is someone very sleepy, someone very lazy. The reservoir don't like to produce, he want to sleep. Okay, so and this is a very important problem, because whenever we have a low pressure reservoir, it means like how you would pressurize this reservoir and make it and you want to change that behavior to make that reservoir want to produce. It's too complex, especially with shale, because shale, I cannot use water flooding, I cannot use gas flooding, I cannot use any of these techniques because the permeability is extremely low. So if you have low pressure, it means this formation will be super lazy, and whenever you frack and perforate, you will produce smaller amount of hydrocarbon, not as much as you may expect. I wish this clarifies, I will just answer the question.
Okay, Dr. Ahmed. Abdul Wahab say it's not a question, but it's more a request. Can the doctor guide us to references related to Sweetspot Quality Index?
Okay, the Sweetspot Quality Index, mainly it is a technique developed by myself and a team in 2015. So you can go to One Petro. One Petro has all the papers, and write Sweetspot Quality Index. I believe you will find two papers, one published at the SPE and one published at SPWLA, and you will find my name on both of them. So you will just write, go to onepetro.org and write Algarhy, Algarhy, Ahmed, Ahmed, Ahmed Algarhy. You will find all my papers, and you will find something titled An Innovative Technique to Grade and Scale Shale Spots. So these are the papers, and easily I can get you these papers and put them in your classroom, Google Classroom. So we can do that. Also, another valuable paper, the paper by Jarvi, the paper, I showed you a very big table, including a lot of information. This guy, Mr. Jarvi, he did a lot of work on evaluating shale. So this guy, I believe, published 1 or 2 papers about that subject, and both of them were great. Okay, do we have more questions?
No, the question is over.
Okay, so guys, there is 3 quizzes will be posted today evening. So starting from tomorrow morning, you will find the 3 quizzes on your Google Classroom, and we will give you a week to submit them. So,
okay. Thank you, Dr. Ahmed Algarhy, for this very good lecture and explanation.
Thank you very much, and see you tomorrow. Tomorrow will be the last lecture. Thank you. Bye.